Hello and welcome to the webinar on Troubleshooting 101, a beginner's guide to AnyLogic model errors. My name is Arash Mahdavi, and I'm your host today. Today, as our guest presenter, we are thrilled to have Tyler Wolf-Adam. Okay, so let's start by taking a look at the agenda for today's webinar. We'll start by some introductions, then we'll see how we can navigate through an AnyLogic model. Definitely, this is going to be for beginners, but it's a good idea in case you don't know how efficiently go around the model, which is something like a prerequisite for a proper troubleshooting a model. And then we move into the two main types of troubleshooting, compilation errors and runtime errors. And at this point, I wanted to mention something just to clarify a concept if you haven't think about what debugging means versus verification and validation in a simulation context. I personally think, or I prefer to separate debugging from verification. I consider debugging as when you are looking into a model to figure out if it actually compiles and run, and the code is all consistent and free of any, let's say, programming errors. But that would be just the first step. Right after that, you need to make sure the model actually matches with your specification. What I mean by a specification is all the requirements and the description of the model, the way you know what is going to happen is digital version of reality. And you usually gather that by talking to subject matter experts and all the stakeholders of that real system. And then you put it into a specification. In the verification step, you make sure that your model matches with that specification, which means that, for example, if you have written that at 8 a.m., there will be 2 trucks moving from point A to B. When you run your model, you will see at 8 a.m., 2 trucks show up and move from A to B. But that is not where we stop. We also have the validation phase, which is probably the hardest to do. And that's where we wanted to make sure the output and outcome of the simulation actually matches with what you see in reality, which is a whole different steps that needs to be done. And both verification and validation is outside the scope of this webinar. We wanted to solely focus on, let's say, troubleshooting and debugging of the model to make sure it actually works and it's runnable and you can actually start testing what you put into a model through this environment or simulation creation environment. After we do those things, figuring out the compilation or runtime errors, we'll also look into the fundamentals of logging. There are different ways to do debugging. AnyLogic has a professional debugger, and you can go in full professional mode and use all the kind of common tools in programming to control the execution of your code and look into all the details. That's not the intention of this webinar, and it only works on mostly code-heavy models, which would be a small number of models. And also, the good thing about logging is that it's going to work both for debugging, verification, and validation. So that's why we're going to focus on that approach to troubleshooting or kind of reviewing a model as a whole. So it helps you along the way from creation up to the verification. And at the end, we will show you some more resources so you can use them in your journey in creating all sorts of models. And also, I want to mention that aside from these conventional methods of kind of debugging the model, we are also going to use ChatGPT as a new way of getting assistance from another newer tools and see how it can theoretically help us with figuring out the error messages faster or in more context and depth. Okay, so the first thing, if you're new to AnyLogic environment, I wanted to show you the name of different parts of the UI. And what I'm sharing with you on the screen is from AnyLogic help. You can find it on help.anylogic.com. And this is from the AnyLogic UI entry. Just some naming of different sections of the view. So you have menu on top, you have this toolbar. There are a couple of windows or views here. We have projects view, palettes, palette view. At the center, we have the canvas, which is the graphical editor, the space you have to drag and drop the elements and create both the logic and, let's say, a physical representation of your model. And on the right side, you have properties window, which is a context-based window. So depending on what you select, you will see the properties of that selected object. And down here, you have the status bar. And these two are the two windows that we're going to focus on mostly today. Problems view and console, which shows us the error messages that we're looking for. So let's go to AnyLogic itself and close the welcome page. So this is what we were talking about. And here, if I, let's say, start a new model, you will see that all of those views accessible to you. And what I'm going to say is not necessarily correct, but it is something that you can have in mind if you're new to this environment. There is kind of a flow from left to right. So this is the global view of all the models that you have. On the projects view, you can actually see all the models that you have opened. Just be careful that you can have more than one model open at a time in your workspace. Specifically for beginners, that might be a source of confusion. I highly recommend you, if you're new, just to focus on one model, select the one that you want, right-click on it, and say close others. But we'll assume that for some reason you want to keep them all available to you on the workstation or workspace, and we'll continue with that in mind. So you have the model. On the projects view, we have the palettes. As I said, in the center, you have the canvas and properties. I'm going to focus mostly on the projects view and show you how it can help you to navigate in a model. Okay, so let me open a model like from the examples, and let's say distribution center. So you will see that this model has many different agents and components in it. It has all these agent types, the experiment, and so on. But the good thing about the projects view is that you have this tree-like access to all the components of your model, and you can expand and see things in a very organized way. Otherwise, your model, if you look into the model itself in the canvas, all the elements that you're looking at are pretty dispersed around different agents and the visual graphical interface. So here you have all of them sorted out into different categories. So you wanted to add something here?
Yeah, just one feature that I really like is that, especially if you have multiple models open, as you do here, in this case, they both have main agents. One easy way to tell which agent you're currently looking at is by whether the text is bolded. So in this case, because you've opened up the forklift agent, that forklift text in that the projects panel is bolded. So
Yes.
that way you could tell at a glance where you are.
Exactly. And by double clicking on any of these agent types, you open up a new tab and gives you the access to the graphical editor specific to that specific agent type. And you can close them. And as Tyler mentioned, if I close this and go to main, you see main is now in bold. So this is a great way to navigate through the model and find the element that you're looking for that belongs to a specific agent type or part of your model without actually physically looking for it in the canvas. So that would be the first thing to start with. The second thing would be if you wanted to, for example, let's say on any of these things, on forklift, you go to variables and you wanted to take a look into this in use variable. If you double click on it, what AnyLogic does, it opens a new tab and I double click again. It first opened the agent type and the second double click actually selects that specific object and puts it at the center of the canvas. You see it's exactly at the center of this white in a space. And on the properties, because this is selected, you see the properties of this specific object. So this is a key information to know about, because as we go through the debugging process, you need to find these problematic elements. And this is how one of the ways that you can find them. You will see later that as we kind of compile the model and we see some compilation errors, there will be some markers with red X's close to the actual problematic element. But now there's no problem. So we just figured out how to find and visually put it at the center of the canvas. The second way to look for a specific item is by searching for it. And you have the search icon here, or you can press Control F on your keyboard and this pop-up window shows up. And here you can actually type what you're looking for. Let's say I know that I had this variable called in use. I press Enter. And now you see a new, the search view pops up and it shows me that under forklift, there are several variables and there is one that's called in use. And the name of that variable is actually what you put in the search box. So, and also you saw that there are a couple of other agent types here. And if I expand that under agents, you see we have several blocks, these rack or a store block, I guess they are. So a rack store blocks. And if I double click on the actual parameter value, it shows me that this parameter is used on some of the actions callbacks of the specific block. And the same thing could be for a body of a function. If I double click, puts that function at the center of the screen. It's very small because I zoomed out. But here you're seeing the body of the function that we have in use variable being called. There are other things here, like it lets you to actually select between a specific model that you have open, or if you just go with a default, it searches with all of the models that you have open in your workspace. That's why I was telling you that if you're new to AnyLogic, it's not a bad idea just to close everything else and just focus on one model. And there are other things that you can do here in this with this search tool. You can make it case sensitive, or you can use regular expressions, which is a more advanced way of matching patterns instead of literally looking for a specific string. That is something that you can use ChatGPT for. We don't have time for it today, but that would be an interesting thing to do and use that type of assistance. So I think by now we saw enough about navigating the AnyLogic environment. I just wanted to mention the two views that we are going to use across the rest of this webinar. And those two are problems and console, and they're both here down below. And you can click on them, you can see the problems view and the console. So when we get there, I'm gonna explain more what you can do with it, but just know that these two are here. If for some reason you close them or you can't find a specific view in AnyLogic, you can always go to view and make sure that's activated. If you move these windows and they are at the location that you don't like and you don't know how to bring it back to the original, there's always this tool, reset perspective, which brings back AnyLogic into its default look. So with that, I think we are ready to look into our first main topic of this webinar. Okay, so let's start the first section here. We are going to talk about handling compile time errors or errors that you encounter before you execute the model. So you can compile the model. I will show you how you can do that. As you build your model, you can press compile, and the compiler, which is kind of an internal program in your IDE, or in this case, AnyLogic, looks into the code. There are some rules about the syntax of your code that it knows about. It's just rule-based, looks around and finds the things that doesn't match with the patterns that it expected to be, and gives you these compilation errors, which you have to fix before it can compile and go to the execution of your code. So we are focusing on those things. So all the errors that you will see can be cached before you even run the model. So that's the reason.
Technically, you can, when you go to run it, it will warn you about those compile time errors, and you could technically press run, but then once you actually run it, it's going to immediately encounter an error because you have to fix those errors.
So that's a good point.
Yes.
So you can overrule that suggestion, but it's not going to help you unless there is some very specific case and you're an advanced user that know that just overriding that is not going to break your code. But that's a very different topic. In 99% of the time, you have to absolutely figure out what's wrong with the model before it can move forward. So the errors found during code generation and compilation are displayed in the problems view. That's the view that I just showed you, and I will show again. And as you can see on this screenshot, when this problems view pops up, you will see two things. So you see the description of all the errors that it found and the location. So the location definitely is good to know, but don't worry about it. You don't need to manually go and figure it out. There are easier ways to actually point to the location of the problem. So as I said, if you lost this thing or you wanted to bring it back, you can always go to views and bring this view back. To open an error that you see here, all you need to do is double click on it, and it takes you similar to what we did with the projects view in the navigation section, which we just did. It takes you to the problematic location, and it highlights the text or the bit of the text that is problematic. And then there are these small icons that probably you ignore most of the time, but that is also another way to make sure that you're actually looking into the errors that are relevant to what you're doing. Specifically, if you have several models open or you have a lot of errors and you wanted to kind of deal with them one by one in a specific part of the model instead of just looking everywhere and randomly pick from a variety of different things that went wrong. Okay, so from this point on, I'm going to show you some common scenarios or compilation errors that you may encounter. These are by no means exhaustive. These are just some samples that we chose as a kind of like a beginning phase. But I think they show you a good variety of things that you might encounter. So it covers probably 80% of what you will see eventually. So the first one is this pattern that it gives you some name, like what you see here, for example. If you look into this screenshots, arrival point cannot be resolved to or something. So it says cannot be resolved into a variable or is not a field. And this is the other variety, or is not a field. or cannot be resolved. So the keyword here cannot be resolved. The differences on the rest of this text is dependent on the context of where you were looking in your program, and that code was problematic. Basically, it could be from the same context, or if you're looking into the context of a different object, so it calls it different things, a field or a variable. Or it could be just cannot be resolved if you're pointing to the actual object itself. But you don't need to worry about it. The key point is that it gives you the name of the thing that cannot be resolved. So what could be the problem in this type of scenarios? So this could be that AnyLogic cannot compute the name being referred to, meaning that could be a typo. So there's something about it that is not accessible. So most of the time is probably is a typo, but there are other layers to it. As I said, it's misspelling or renaming. Sometimes you knew the name, but you renamed it later. There are ways in AnyLogic, for example, when you rename, you need to press Control-Enter to refactor it properly. With that way, AnyLogic searches through the whole model and refactor all the instances of that name. But if you haven't done that, you might have missed something, and it has the original name and you cannot find it because of that. So the other case, which is very common, is when you're accessing an object, if you haven't cast it properly, and AnyLogic doesn't know the specific type that object is from, and consequently cannot find the fields or all the things that belong to it. So it throws an error because it hasn't been casted properly.
And I think this will become more clear when we see an example, too.
Yes.
Yeah.
Okay, so I have a couple of models that I want to show you, and we're gonna debug these problems. As you go along the model building process, you can always click on this build button or press F7. And what it does, it looks into all the models that are open in your workspace and finds all the errors that will show up here in this error view. So I click on it to make it visible. But as you see, and if I look into the locations, if I open this, so you see that these are kind of a mix of different errors that belong to two models, both of these. And that's where these smaller icons come into play. So you can click on, for example, you can activate filter by model. And now I can click on a specific model and I only see the errors that belong to this. And I click on the other one that shows me that. The other option that you have is filter by selection, which is even more granular. So you can actually point to, for example, the customer, and you see that there's no error here. But if I go to main, you see some errors that belong to main. And the other way to actually visually see that, in the projects view, you will see that there are some X's to the left corner of that icon, and you can actually expand and really drill down and find the actual problematic object from here. But there are easier ways to get there. But if you wanted to have a visual kind of way of seeing all the problems where they're dispersed in your model, this is a good way to look at it. But usually what you need to do is, for example, I'm going to select a specific model. I'm gonna focus on this model first. So we have 3 error messages here. And what you need to do to easily find them is just double clicking on them. So let's start by this. I double click on it. And as you see, it highlighted the problematic object. And if I double click again, just to make sure, it puts it at the center of the canvas and also highlighted where the actual code cannot compile properly. And maybe it's not a bad idea because we're going to use a similar model across the board to just know what is happening here. Maybe you can explain what this model is about.
Sure. So it's just a very simple queuing model where we have this discrete event flow chart where customers, which are our custom agent type, are coming out of the source and they're seizing one of the resources from the employee pool. And the employee pool is filled with custom agent types of type employee. They're then delayed for some period of time. They release and then they leave through the sync block. And the other component is that when they do leave the sync block, they add their time and system to this histogram data object, which then will populate through the chart. And the other part is that there's some space markups that we have that are referenced within the C's and the delay block, so that when we're running the model, we're able to visually see what's happening.
Perfect. And just to say it once again, as Tyler mentioned, so you see that we have two agent types. One is the customer, which is the agent type of the entities that are passing through the flow chart, and the employee are used for this employee pool. So these are the resource units that are used by this C's block. So that was what our intention was, because all the errors and all the things that you're looking at, you first need to understand what was the intention of the model. Otherwise, errors usually don't mean anything without context.
And the one other thing which I didn't mention is that while the customer agents are within this flowchart, they're put inside, as part of the process, this customer's population of agents. So when they leave the source, they get put inside that population, or at least that's the intention, and then they continue on, and they'll be automatically removed once they leave through the sync block.
Yes, and that's what Tyler is pointing to, and this is our first error actually, that when you create agents from a source block, you can add them into a custom population of the same type to have more access to them. Otherwise, you just add it to a default population in the backend that you don't see. So here, it says there's some problem. Just by looking at it, I can see that this is the name of this is different from this population. There are other ways to just look at it. So definitely you can type and use control space to bring in the code completion master. But I think if I go back to this and change it from code to kind of a drop-down menu, it also helps me with picking or choosing the correct one. So again, you have different ways to do it. So right after I made that change, I will try to compile again to see if that actually helped, which it did. So now we are dealing with two. And we continue the same process. We double click on the other one. And now we see this code. And as Tyler mentioned, the intention at the end is to add the travel time, let's say, for these agents, the time they spend in this flowchart to this histogram that later we use to visualize with this histogram graph. But it's kind of complaining about the flowchart and says, I cannot resolve this. So just by looking at it, I can see that the name looks similar, but the typos are usually one of those things that are really hard to catch and it's time consuming. The easiest way in these scenarios, at least for me, I just remove the part that I can read by just a glance, and then I press Control Space. So this gives me some suggestions about things that might match with what was there. And as you can see, there was a typo there. The T was lowercase in the original. So I press Enter and I substituted that with the correct name. So compile again. One more to go. So it says arrival point cannot be resolved to a variable. So this kind of a similar pattern, double clicking on it, it says this is where we assign a physical or graph, kind of like a visual representation location to the incoming agents. We can select a node, and in this case, it says it should point to arrival node. So kind of complaints. Logically, I know that it should be somewhere here. So let's click on this. So it says arrival point. So let's go back there. So let's try this trick of control space again. So as you see, it didn't work. So it doesn't show me that arrival point, but I kind of can see it here. So what's going on? The name is correct. So what is happening here is if I zoom in, you see that this is grayed out. It's supposed to be blue like the line, but it is grayed out. And this is something that might happen if you can see visually something in the space markups on your variables or functions, but it doesn't show up in the
Code completion.
Code completion. It means that it probably is ignored. So I bring it back. So now it is there. I still have problem. So the original was correct, but because I changed the name, so now I press Control space. It gives me the suggestions and compile again, and all the problems on this model is gone. Okay, so let's take a look into the second model. Again, we are dealing with similar type of errors. Double clicking on the first one, it takes me to the C's block. It says these the tasks that are coming in or the agents that are coming in, which are our customers, are going to have some priority. And says this agent has a priority value, but it says it's not a field. This belongs to an agent, and the agent type is customer. So looking, what I would do is just to go to the customer, double click there, and take a look into its fields or parameters, variables that are there. And I see that the priority actually called priority level. So that was the manual way. The other way, if you kind of know what's, you knew that the name was similar, but you don't remember, you don't want to go back and check. Let's do it again. I double click to take me straight to the problem. Looking into this field, I know that it belongs to this customer agent type, and it says I cannot find that type of variable or parameter. So I go to the customer, double clicking on it, opens it up, and it shows me that it has a priority level. I'm gonna just know that this is probably the name that we were looking for. Going back, double clicking on the error, and I'm gonna change priority value to what we had there, priority level. So let's see. So it's definitely there. And if logically that was what we were looking for, this should be okay. And I know because we created this model, but this is something that, again, depending on the context of the model, we knew that we were looking into the specific variable or parameter in this case, and we corrected the name that we were referring to. So the next thing would be this. So I think it's a similar pattern, but this time it says a skill rating cannot be resolved into a field. Okay, so we look here, we see that this unit, which points to an resource unit, supposed to have this skill rating, but it cannot find it. Let's see if it actually exists in the agent type that belongs to it. So we go to the employee, and it is actually there. So the problem is not the naming or the way we refer to it like the previous one. So something else is wrong here. And that is, again, you have to have some knowledge of why this happens. In AnyLogic, in these fields, we are in the seize block, right? So seize block, the context, so it assumes, so when you point to a unit, it does not necessarily know the specific type of that unit. So you need to do a bit of typecasting before this is going to work. And in this case, our agent types are going to be employee. So you need to do this. Right? So you first, you need to pass the name of put the name of the agent type inside parentheses before the object. And because this skill rating belongs to the entire object, this entire thing also has to be inside parentheses. So we first casted that unit, and now we have access to a specific field that belongs to it. So let's see if it recognizes that. Yes, so we're good to go. So that was the first type of errors that we wanted to look at. Let's take a look into the other ones. Okay, the second type of compilation errors is when the argument that you're passing to a method or a function does not match with what it was expecting it to be. So the error will look like the method, the name of that function with its argument in the type. This would be the name of the containing agent in the context of AnyLogic is not applicable for the argument. And it gives you the argument that you passed that does not match with what it expected it to be. And as you can see in this example, the method add double. So the method is add, this is the function, and it expected a double, one value as an input to it, as an argument. In the type histogram smart data, this is the object that owns this method. So it gives you all the correct things. Up to this point is what it's supposed to be. Is not compatible with the argument customer. This is what you passed into this function. So you basically pass a customer instead of a double to this add method that belongs to histogram. So let's take a look at it. Inside AnyLogic, again, I have that model. I can go to the compile and bring in this. This is the error message that we were talking about. Double clicking on it will take you to here. And as you can see, we are kind of passing the agent, which is the customer. And if I pass like a value that is like an integer or double, it correctly register that. And there are another example here that we don't want to look at, but that's a very easy pattern to recognize. The arguments that you pass to a function should match with what it expected to be.
And what I'll point out here is that the second error refers to a function that we had created within the model, which in this case is the one right above the delay block. So this is true for not only the built-in functions, but also any custom ones that you create and try to use within your model.
That's a great point. And now that you mentioned it, just quickly looking at it, is that this custom created function has two arguments, and this is what we created. So the type is created by you. So you said there are two arguments with that are two doubles, but when we use this, let's double click on the error, we only passed one value. So it needed two, right? Something like this. It's very easy to debug this type of error. So let's move on to the next type of errors. So this is a very common scenario that you wanted to ask for some information from an object or do some task with it, but because you assume it to be a different type or you haven't specified the exact type that it is, you're going to get something like this, the type mismatch problem. And if you look into the error messages, it usually gives you a very clear indication of where the problem is, and there are two things that could have happened. Either you made a mistake and that your intention was not to pass, for example, a Boolean as a double, or you might had some idea that this might be registering as a Boolean, but it does not. So then you need to go back and refactor your code to cast it properly, or do something to transfer maybe that value to the proper one that is expected. So let's take a look at an example of this. So in this model, I compile it and I have two errors. Type mismatch, cannot convert from double to Boolean. Double click and see where the problem is. So here we have a condition. So it definitely requires a Boolean to be passed to. An agent has this specific field, has complex problem, and it's a customer. So I'm going to the customer and see what we see here. So the type, so what it actually has as a default is correct, but the type is set to be double. So all we need to do is to just make sure it's a Boolean. And if I compile it again, it will kind of solve all the problem that was here. So just, this is a very straightforward message. It tells you exactly the mismatch between the types.
So, and to clarify further, the two error messages had the same exact cause. So one error was because in this field, we had set it as a double, but the random true function returns a Boolean. So we were trying to assign a Boolean to a double, which is one error. And then the second error is in our usage or implementation, we were passing what we defined as a double to a field that expected a Boolean. And so that was the mismatch between the two.
And that's a really good place to mention this, that sometimes one problem might have a cascading effect and you might get 10 errors, but it's actually one. So usually, and that's a good point to bring this up. That's why it's not a bad idea to keep compiling your model along the way. Don't wait till you have made 200 changes and you compile and you have 2,000 errors. So you don't want to be in these situations because of this cascading effect. Some of them are artifacts of the other errors, and now you have so many errors, and it becomes unmanageable. But if you compile it, let's say because of one problem, and we'll see some examples that might do that, it generates another 200, you know that you only made one change. So it's easy to go back and be confident, make that change instead of just dealing with something that looks very scary at that point.
And I think for that reason, if you are troubleshooting a problem that has, I mean, I don't know about 200, but if there's, many different problems, to start debugging them in the order that you feel most comfortable with. Or if you tried, if you couldn't figure out one error, just move on to the next one, and it might end up resolving the first one in the end.
Okay, for the next kind of generic type of messages, we need to just have some definitions here. We don't want to get into the details. Just briefly, you see it on the screen. You can read it. So we have a token, which is a single character. Expression is Java, is some variables and operators and functions that evaluate to become one value. So something like this. And if you calculate it, it becomes one number that you can put into a variable. So that's an expression. A statement is like a complete unit of execution in Java to do some tasks, and it ends with a semicolon. So this is the statement. In this case, the expression is this, right? So this is the whole a statement. So here, this is the whole statement. This is the expression. And a block statement is usually, so as you kind of arrange your code, you have more statements that work together and they become part of the code that you wanted to separate, and there is some context to it. So they know each other, and there are lots of things that goes with it, but we call it block statement. And they get this context by curly braces around them. So just know that, which helps, knowing that helps us in kind of understanding better what these error messages mean. So it tells you a syntax error with some message. And you see kind of very common ones here. In the case of having an extra character, it tells you that I think this token is extra or is out of place. Sometimes when you're dealing with expressions, because it evaluates that expression, you have parentheses for your functions, for the way you create your mathematical operations. So if you have extra or less than needed, it tells you that would be, and it mentions that it's an expression that is problematic. And a statement, the most common one, you don't have a semicolon at the end. It says, I think there should be an end to this. And the block statements, you might have extra or missing curly braces. And this is one of the ones that might result into these two have the tendency to completely break your flow of your code. And you might get many errors that are just the result of a missing curly brace or like a semicolon.
And part of that is due to the reason that behind the scenes, when you build the model, AnyLogic is converting the visual and graphical elements that you created to pure Java code. And there is auto-generated code that comes as part of that. So if you add, 3 closed curly braces, you might be closing the curly braces for some of that auto-generated function, which causes this chain effect.
The next one is unreachable code. So there are ways that you can end or terminate the execution of your code or the flow of your execution. And for example, return keyword is a very common way of doing this. And if you're not dealing with some form of conditional or a statement that has different flows, when you get to the return, that would be the end of that specific part of the code. And if you have something right after that, logically, that part of the code there's no way to get to that point. And it gives you this error message that there is unreachable code, to give you a hint that you made a mistake and you probably expected to be part of the logic, but it's not. So we're not going to show an example. It's pretty straightforward. And then this is also very straightforward. If your function name is something you made a typo or it's not accessible or because you renamed it and we didn't refactor it properly, similar to what we saw for the objects and variables, you get an error message, but this time it says the method and the name of the function is undefined for the type, and that would be the agent type or the context of that method. So we have some examples. By the way, we created some example models that generates these specific error messages. We will share those with you so you can actually practice with them and debug them as we demonstrated here. We demonstrated the ones that are harder to find. These are super easy, so you will figure it out on your own. And the last thing is there are some compilation errors that are specific to AnyLogic. To help you with specific constructs or model building constructs and methods that are inside AnyLogic, like flow charts, or in this case, state charts. It gives you very specific pointed kind of error messages to help you to remedy the logical inconsistencies of what you have created. I have a list of probably a majority of what you see in the case of a state chart. Okay, so I'm going to create a couple of these errors so you can see them in action and how they look like. Let's go back to AnyLogic and And these are mostly, in the case of state charts, are dependent on the rules that you need to obey when you're creating a state chart. For example, I just added an entry point, and it gives me an error hanging a state chart entry, meaning that you have an entry, but it doesn't point to anything. So if I add another state, it goes away. The same thing goes for example, a transition. So now I have a hanging transition. So if I connect it, that goes away. But like there were a couple of errors, but now it says a hanging transition. And it actually turns into red. So there is a visual way of seeing that. So now I have a hanging transition and an element that is not reachable because it's not connected to it. So if I do this, both of them go away. So if you're in the middle of creating your state chart, those are okay. So you know that you're going to fix that. But just know that these are things that could happen. And there are more advanced ones. For example, if you have a branch, let's say we go to a branch. This branch, again, see an error, branch state without outgoing transition. So you get into this branch or conditional path, but there's nothing to get you out of it. And there are other things. For example, if you add these, and I can actually have a state, so they are not hanging. So let's actually connect them. So you see that even if I have, it says too many default exits. If I click on it, you see that both of them by default are set to be the default, or imagine as the else part of your conditions. So at least, so you only can have one of these default. So you can fix them as you go. So there are many of these things, but the good thing is they are kind of live, and as you make the changes, it gives you those error messages. Okay, so now we have seen a variety of compilation errors. That would be the first class of errors that you see before you even run your model. But even if you have cleared all those errors and everything look fine, when you run your model, you still might encounter errors, which are runtime errors. And Tyler is going to walk us through those and show us some examples of what could happen.
Okay, so now on to runtime errors. So these are happening during the execution, and these types of errors relate to the rules that you put in place that were technically correct, but due to the conditions as part of the running code or the running program, it causes logical errors. So this can relate either to the Java code, which most of the time when these happen, they are issues with code that you've written, or it could relate to the simulation logic. The differences between these are essentially the same. When you encounter one of these during the model run, you'll get a pop-up error, and then what will be printed to the console is a message in what's known as a stack trace. So to go through the parts of what you see here, so of course this might be rather intimidating with the wall of text, but I'll break it down so that you have an understanding of what you're looking at. So sometimes at the start, there will be a message, which is kind of reiterated over here. This line right here will show you the type of error that had happened. And then what follows below is, like I said, what's known as the stack trace. This is essentially the sequence of function calls that were made within the running program that led up to the error, kind of like a game of telephone. And it's ordered in terms of most recent at the top to the furthest back at the bottom. So in this model, just to go through this example, I have a main agent with a factory's population. And inside that factory, my factory agent, I have workers population, which is the my worker, and it has the state chart. And so I set it up so that in the model, when I click on one of these users, it moves into this requested state. And as part of the timeout, it calls this function. And this function calls the function within the my factory, which itself then calls the delay formula within main. And if we look at the stack trace, you could see at the oldest call, it was something to do with the engine, which we don't need to worry about. And then a message transition occurred, it entered a state, and then the transition timeout. Again, I'm just kind of breezing through these, and this is what you should be doing. It's just kind of very lightly looking at these for keywords that you can understand and make sense of. I'll also point out that in all of these, it's mentioning the package name, or the, in this case, the model package name, the agent that it executed in, and then the name of the function. And some of them also have this blue text here. And this is, if you click on it, it will bring you to the source code if it's available for where the error occurred at. So again, keep going back up. You could see that I have my worker agent where it was called, and this goes into my factory and then the main agent. And if I were to click on here, it would bring me to the auto-generated code, which shows that the division by 0 happened, and it will highlight this line here. And I know from having made this model that the error is due to dividing by this value, which if I clicked on the agent with index 1, this would cause the division by 0 error. So the point here is not that you need to be very well versed in this, but just that to get a general idea of what you're looking at when these two happen. So what's most important is if you focus on this very top line, because most of the time this will refer to some code within your model. And in this case, the code was referring to the content within this function here. So what I could do if I was trying to troubleshoot this is to copy this line and then use the search functionality to find where in the model this code was actually located. And so now going forth, I'm going to run through a few different common runtime errors that you'll encounter. And then, like Arash was showing before, I have some models where we can walk through, what's causing these to occur. So the first one to look at is agent cannot leave port, and then it lists the name. It has no connections. And this is related, this is a simulation logic related error, specifically when it happens with flowcharts. The name refers to the your root agent, typically main. In this case, it's the short delay object and then the out port. So this is where it's complaining about. And specifically, it happens for certain types of blocks. So if we go to the equivalent model, we could see that, let's say I was testing some flowchart logic, and I have this flowchart that ends in this delay block. And so if I build the model, it will show no errors because this is technically a logically sound flowchart. But once the agent actually gets to this delay block and then tries to leave it, it will cause this error to occur at. And so there you could see the stack trace for this problem. So in this case, I would need to, if I didn't want that to occur, I would need to add some other block that could either safely hold the agents, like a queue block, or terminate it with a sync if I, for example, didn't need those agents anymore. This next runtime error is one that a lot of beginner modelers will see and be very intimidated by, and it's another simulation logic related error, specifically, again, related to flowcharts, and it happens commonly with source blocks, which use the push protocol. And when an agent tries to leave that block and cannot due to downstream blocks reaching capacity, there'll be a logical error. And this is actually a good thing within your model. It's not a problem, because if this didn't happen and it tried to push an agent into a block that was at capacity, that would break down the logic that's structurally fundamental.
Yeah, so in other words, it breaks down the logic that you were looking for. Nothing will happen, but if your arrival was 10 per hour, it might turn into 2 per hour without you knowing. So it tries to push you to realize and acknowledge that it is not what you specified. So if that was not your intention, you don't get the wrong outputs and just continue that mistake.
Absolutely. So similar to before, it will tell you things like the name that the problem occurred at, and then also give you a date and timestamp. And this is extremely useful, especially and particularly if you have the fixed seed option enabled within your simulation settings. So if we go ahead and run this model now, and I'll just speed up time. Now, if you were just running this model normally, so here we could see that error occurred at. Again, that's the same timestamp that you had seen before. And you can see that we've gotten to a point where the queue capacity is about to be exceeded. Now, if you wanted to be able to replay this, to be able to recreate the scenario and step through the logic, maybe it didn't make sense why this might occur. Again, having that fixed seed is vitally important so that it happens again and again, and you can reproduce this error, especially in terms of if you want to, for example, send this to the support team or ask others for help. Having a reproducible problem that you can step through the problem is very important. So here what I'm doing is I went into the developer panel so that I could run the model up to the moments right before that happened. And so now I can go to this event tab and step through the model logic one by one to see the sequence of events that caused this to occur. So you can see that it reaches 10, and then right as it's about to output it, one that would exceed that from occurring, it would cause that problem. So, and in this case, some of the model logic errors that come up, the message poses some suggestions as well. So we could increase the capacities, or we could switch the block to do a pull protocol.
So Tyler, I actually tried this and put this stack trace on chat.
Yeah.
But do you want to try this?
Yeah, sure. Getting this error when running my simulation model, can you help? And then I'll just put this in triple brackets and see what it says. Related to the movement of agents, specifically it states that an agent was not able to leave the port at a certain time. And then I guess it parses the message that AnyLogic provides. But what's interesting and very helpful is that it actually explains what both these things mean. I think especially when I was beginning to learn about simulation, having this full explanation about using pull protocol is very useful, especially as a chat will allow you to ask follow-up questions. So I could say, can you explain pull versus push in simpler terms? And then have a dynamic conversation with this to learn more about it.
Yeah, so you definitely have to consume this feedback with a grain of salt, knowing that it may not be all correct, but definitely what it does is meaningful. So reading through this, I tried a couple of these and the suggestions were on point. But again, be careful, don't just rely solely on this, but it definitely can be a assistant to you, just deciphering some of these stack messages. Yeah, so specifically for beginners, or sometimes you don't have the patience to read through it, so you want a simpler explanation in a second. So that's worth.
Okay, so for this third runtime error, this gets into a little bit more complicated territory, and it can happen when you're dealing with Java code that relates to the typecasting that Arash was explaining before. And to expand upon this, when you create a custom agent type, so there's the base agent type, the generic agent type, and whenever you create your own custom agent type, what's actually happening is you're extending the functions, the variables, all the components that are within that base agent type, and that's inherited to your custom agent type. And as an example, in my employee primary agent type, which I'll be showing momentarily, if I call the code completion on a empty field just to see the different objects that are available. What I'll point out here is that at the end of each one of these lines, it tells you the object type that originally had defined it. So in this case, things like the shape for the group, the level, the presentation, these all belong to, and the skill rating parameter all originally belong to my custom agent type. Whereas these functions, which are commonly accessible throughout any agent type, is because they're all extended from the base agent type. And for certain callback fields, it uses this, it mentions the type as this generic agent because of the fact that you can have multiple different custom agent types in that field. So to explain that, let me go into the example and it should make more sense there. So in this variation of the model, rather than just having one type of employee, we now have two types. One is the primary employee, which has a skill rating associated with them. And then we also have a backup type of employee, which is meant to be a secondary choice. And because of that, we have two different resource pools. So in our C's block, it's been set up such that when customers first come in, their first priority is to pull from the primary employee pool. And in case there's no employees that are available from that, it will, as a secondary option, pull from the backup pool. The resource selection has been set up such that it will, we want it to choose from the employee with the highest skill rating, which is available in the primary employees, but not the backup ones. So currently, again, there's nothing wrong with the syntax of this model. However, once all of the primary employees try to, or are in use, and a backup employee is attempted to be used, it tries to cast or convert the employee backup to employee primary, which is what is problematic because one doesn't descend from the other. If we go back into our C's block, we can confirm that if I just start at a blank empty context and then call the code to completion. You can see the local variables that are available here by the L, and you can see that the unit keyword is actually a generic agent type. Now, as Rash was showing earlier, agent is a customer, but because of the fact in resource or for C's blocks, as you could see here, the resource unit can be any number of agents, agent types that are your custom type or a generic one. What AnyLogic does is it casts it to the highest level type, which is agent. And if you want to utilize any attributes of the actual type, you have to typecast it. Now, the resolution here is to check what the actual class is of the unit. And we could do that using the instance of keyword. And I'll have a ternary operator. So I'll check if unit is an instance of employee primary. And then if it is, which I'll, you then add a question mark. And then if it is, it will be whatever the first expression that you have here is. And if it's not, which we then separate it by a colon, then we have the false condition. And I'll just say 0. And if I rerun the model now, just to make sure that that works as intended. And now you can see that both resource pools are being utilized without any runtime errors. Now, just very quickly, just in case this ternary operator, you're not familiar with it, and you're not comfortable with it, we could also very equally create our own function. We'll call it get unit rating, and we'll mirror the inputs and outputs of that field. So we want it to return a double, and we'll have an argument for unit, and that will be the generic agent. And so here we'll say if unit is instance of employee primary, then we'll return we'll typecast it to employee primary and then get its skill rating. And then otherwise, we will return 0. And if you want to, you can add curly braces, or technically we don't need this else statement. But now what we can do is, rather than having that ternary operator, we can replace this with get unit rating and then pass in that unit. And this will work just the same. Okay, for this next runtime error, this is the most generic one. Probably sometimes harder to debug because of how generic it is. But in Java, null is a keyword to indicate a lack of a value, and it's used both as the default value of whenever you have a non-primitive object type, for example, agents or colors or positions, but it's also used by functions to indicate the lack of output. For example, if you use something like a random where function, or there's a couple other built-in functions that search through a collection, if the condition is part of that function call isn't met by any of the agents in the collection, for example, it will return null. And so when that happens, you need to, for any case where you might want, or there might be a null output, you'll need to check for whether that return value is null. But if you try to do any sort of operation, like adding a value to null or calling a function as if it returned a intended output, it will cause this null pointer exception. So in this example, again, we have our baseline example, but now in our customers, we have a complexity rating for their call or their request, and it's a number between 0 and 3. And then our employee also has a skill rating, which at the start will be based on their index. And because there's 3 employees, this will be 0, 1, and 2. And what we want to do is when the customers first arrive, we assign them to an employee, and then they're seized by that specific employee. So in this case, we have a variable set to type employee. We leave this blank, which will end up being null. And then in our source block, we choose a random, we assign the value of that to be randomly from a population of employees, where the skill rating of the employee is greater than or equal to the complexity rating of the customer's problem. Now, what you'll notice is that the values that I chose for the ranges, the customer rating can get up to 3, but employee rating can only get up to 2 because of the fact that we have the index only goes up to 2 because we only have 3 employees. So in that case, when we try to seize by choosing the unit with that assigned employee that's in the agent, if this is null, we'll be trying to do null.equals unit, which will ultimately cause an error. So what we would need to do in this case is either have some sort of fallback value or handling for that, or in that seize condition field, we'll need to add, again, a ternary operator that checks if this is null, and if it is, then we handle that accordingly. And then in the stack trace here, you could see, again, we're going to ignore most of the bottom part of this, but looking at this top line, if we were to click on it, you could see exactly where the null pointer exception occurred at. And we can infer from that the problem is with this. For the last time runtime error that we're going to be running through here, it's the index out of bounds exception. So this happens when you're trying to reference a index or a numbered position in a collection that's invalid based on the size of that collection. And so this invalid index can either be anything below 0 or above or equal to or above the size of the collection, because of the fact that Java starts counting at 0. So if you have a collection of length 2, the only valid options are 0 and 1. Looking at the example that I have here, here we've added some view areas to both main and the different customers. And in the customer agent type, we also have some control options, which will, if you press this left button, it will get the index -1, so the previous index of the current customer, and then it will try to navigate to the agent with that. And then the same thing goes for when you're clicking on the right button, it will add 1 to that. So if I run the model so that we have some customers, so, and then I go into a random one, you can see that we're currently looking inside customer with index 0. So if I do left, it will try to index the customer's population with a value of -1, but you can see that that's invalid. On the other hand, I can go the other direction. And once I try to go past 3 to 4, because of the 0 indexing, the maximum value that's accepted is 3. And so then I get it with the other way around. And so in this case, ways that you can, again, the stack trace will point you to the area that occurs at, and you can handle that by changing the enabled status of the button based on the index, for example. So all of the problems that we've been showing today have been extremely simple. And of course, as you're going through the process of building your models, there'll be a lot more complexities. And so naturally, you want to add some logging during the model execution so that you can keep track of various different things that are happening over the run. And there are, if you're wanting to do a robust method of logging that has a lot of customization and features, you could use any one of the many third-party Java libraries that are available. Of course, the problem with these is that it requires you to know how to access, download, import, and utilize these libraries. But fortunately, AnyLogic provides some simple tools that are extremely flexible and capable. And so what I'll be focusing on is the traceLN and traceDB functions. These are functions that have multiple different possibilities. So depending on the number of arguments that you pass and the data types of them, it will use whatever version of that function is appropriate. So it allows you to do things like coloring the output in the console or using text formatting, or there's options for just outputting a blank line or a single object as well. There's also the trace2DB function, which will allow you to do something similar, but it will write to the built-in logging database. And I'll talk about some of these other things as well that can help you to standardize your own style, like customizing your own functions and having different parameters. So for this, I have, again, this baseline model. What I'll do is, for example, in the source block on the onExit, I will print out attributes of the agent itself. So to start, I could just do traceLN agent and then run the model. And so now if I open up the console, you can see it prints out some initial generic representation of that agent. If I want to, I can customize that. So if I go into the customer agent and in the properties and scroll down to the bottom, there's a button to create the toString with parameters, and it will create this function. And so now whatever you put here, whatever you output here, will be what's shown in the output instead. So this is the aforementioned toString function. And you can customize this however you like. To combine some of the different variations, I'll show you one other thing, which is to have both coloring and also string formatting. So in terms of coloring, that would be the first argument. And AnyLogic comes with a variety of named functions. So for example, I could just type in blue. Now, if we're wanting to put, for example, the model time when they exit in addition to attributes of that agent, the traditional way to do that is if we wanted to maybe put the time in square brackets, we could use the plus sign to concatenate strings with other values. And then put agent dot complexity rating and then close that. So this is one thing that you could do, and that's completely valid. but the string formatting is very powerful and allows you to kind of organize visually the text a little bit better. So we'll provide some links to where you can read more about the string formatting, but in short, the simplest one is just the way that they're all structured is a %, and then maybe some numbers, and then different letters to indicate the data type. So if I do $10s, that means it's a string, the s, with padding of 10. Or another one is 10.3f means 10 spaces of padding with 3 digits of precision, and it's a float. And then I'll just do s for the second one. And so now I can put a comma, so I close that quotation, and then I could just put the values themselves. And so these two lines are functionally equivalent, but you can see I don't have to worry about, the concatenation of strings. And just to contrast, I will also, when the employees first come out, or when they're first created, I will print in red the unit's skill rating. And so now if I run this, now the coloring doesn't happen in the console view, but it does happen within the this panel, the developer panel here. So you could see the values are in red, and now I have this padding. So there's 10 spaces of precision, or 10 spaces for padding with those 3 digits of precision. And so to add to this, if you wanted to, for example, utilize a certain format across your model in multiple places, you can create your own global functions like custom log, which which just takes a single argument of object, which is at Java's point of view the highest, most generic data type available. So we could do again similar to what I just did before. And so now what I'll do is print out the time and then whatever object is passed by the user. So now rather than having to copy paste this to have this standard format and everywhere in my model that I want to use it, I can now call this function in all of my various different places that I want to have some representation. And then I can have that format that's available to me. The other function that's available is especially useful if you have, if you want to have this exported to Excel, for example, or you have other forms of model logging enabled. This works in a similar way, but allows you to also write to the DB, the database. Actually, as part of this custom function, maybe what I want to do is have it not only print to the console, but I also want to print to the database. So again, rather than having this across my model multiple times, 2 different lines for every place, I could just call this one point, and then it will, I only need to do 1 line. And so if I run the model now, I'll let this run out for some time. Stop my model. So you can see the output was here. And now in the database, I have a bunch of logs, but specifically the trace log is what contains all of my messages. So this includes AnyLogic automatically provides the date and timestamp for when that log occurred, and then a counter for the message number, where it occurred at, and then my message text. So these are just some simple ways to get you started with good practices with logging.
Okay, so now that we showed you a variety of ways to troubleshoot an AnyLogic model, let's briefly take a look into further resources, and in case you wanted to ask questions from our support or asking for help from others in the community, how you can actually do it in a more effective way.
Yes. So in terms of resources, of course, the AnyLogic help, which help.anylogic.com or just anylogic.help. There's also links to Stack Overflow, for example, on the welcome page when you open up the application, or if you have maintenance, you can contact our support team either through email or directly from the software, where you can even attach assorted files or models. But in general, when you're initially troubleshooting, some key points is to, one thing that I always try to do is, if I have a complex model trying to troubleshoot a specific problem, if I'm trying to see if it's maybe a bug or something that I'm doing wrong, I'll create a separate model and recreate that problem so I can have a dedicated kind of sandbox environment where I can play around with that. And then, as I was saying before, using a fixed seed is extremely important, especially if you want to, if you have what seems like a weird problem that happens sporadically. Having a fixed seed allows you to recreate that scenario, and so you can go back and step through the model logic. And then using the aforementioned logging helps to track your model.
And if I want to add one thing to what you said about creating that sandbox, the other benefit of that would be if you wanted to ask questions from our support. So you can send that specific, smaller model to them, and it would be easier for a support specialist to open that simpler model and get to the exact problem right away. So it helps with the turnaround of your questions as well.
Absolutely. And the other thing is that when you do ask for help, it's extremely important to be able to have details like the specific conditions that led up to the problem occurring, even any context surrounding either what you've tried or what's going on in the model, what to focus on or maybe not to focus on. Adding more detail is useful in that it gives better context so that they could better help that, especially if you could provide some sort of reproducible, and it's really important to have a reproducible problem so that anybody who's helping you can also step through that and kind of see the chain of events that caused some problem to occur.
So in the same line, specifically when you're dealing with runtime errors, if you know the exact moment in your model time that happens, mentioning that also a key element.
It's huge because there might be someone who's helping you might want to add additional logging statements of their own, and by doing that, it could completely make the difference between getting immediate help or needing to then go back and forth for 5 more emails just to kind of drill down the cases for when a problem might occur.
I think that's all we had for this webinar. As we mentioned, all the models that you've seen here, or the ones that are useful for you to try at home, we'll share it with you. The recording will be on YouTube, and now it's time to go to the Q&A section. Thank you.
Thank you.
Okay, so thank you so much for your time today. I know this one was a little bit longer than usual, and the topic was not as exciting as our normal webinars, but the idea for this one was to, aside from having a webinar that we can interact and answer your questions live, we wanted to make sure that there is some kind of reference for newer users of AnyLogic so they can figure out how to debug their models more effectively. So let's jump into the questions that you had. We answered some of them, but there are a few that left unanswered. So Tyler and I are going to answer those questions. So the first one, I guess it's for you, Tyler. And I think you kind of answered it near the end, but let's visit this. What are tips for finding the underlying issue for errors that have generic messages or relate to some internal AnyLogic concept?
Yes. So sometimes there is some internal errors that come up as the result of something that's happening in one of maybe the discrete event blocks that you've created. These are normally kind of harder to debug. Most of the time, it's due to some custom code that you or the user might have written, like if you're manually doing something with the agents or resources. So typically what I start doing is if I have like a big flowchart that I'm working with, I'll ignore it, select all and ignore it, and then build a smaller scale version of this, try it out, then continue building up to it to try to diagnose where the ultimate problem is coming from. But maybe actually before that, you can kind of step through your own custom code just to try to figure out where that type of problem might occur.
Okay, thank you. The next one is also, I guess, how we can address this one. What if I can't seem to make an error that's reproducible every time?
Yes, so sometimes this happens where certain conditions make that hard, and it's not, it's not a error that happens literally every single time you run the model. In this case, of course, fixing the seed is the first kind of prerequisite. But if you try a few of them and it doesn't work, one alternative method is to run like a parameter variation, even if you're not varying the parameters, I guess. There is, within the engine, you can set or override the current seed that's being used. So if you run 1,000 iterations, each time you could set the seed for that iteration to be that seed value. And so then that way at that iteration, that's a good seed that you can then use to plug back into your basic simulation experiment to then be able to step through that logic more easily.
Okay, I think I answered this one myself. Do you suggest using logging instead of debugging with breakpoints? I kind of said something about it at the beginning, but in general, it depends on the context. But as we discussed here, the logging approach has more versatility across your model creation phases. So you can use it for debugging, verification, validation, and it works better with dynamic models because the errors are usually it depends on timing of when they're happening. It's not like static code. But again, the conventional debugging with breakpoints has its own value in scenarios that you're developing some form of heuristic or algorithm to be implemented as part of your model logic. But that usually happens in very kind of niche models or a specific type of scenarios. So that's why we felt like it makes more sense to focus mostly on the logging approach. Okay, so the next one is for you, Tyler. How should I deal with errors while running a multi-run experiment?
Yeah, so this is common. So often when you're doing a multi-run experiment, if you're using a random seed, it will give you a message like error during iteration 1 or 17. Actually, this kind of ties back around to my earlier point, which is if you override the seed with that kind of one-liner, like get engine set default random number generator. If you do that, then you can rerun that multi-run experiment, then be able to see which seed is a problematic one. In this case, it will cause the same thing to occur, but then you can, of course, like I was saying before, go back to that simulation experiment where you can have that full animation for that run. Okay. And that will also give you more detailed information about that error when you're running just that single iteration.
Okay, great. The next one is, do you think generative AI is helpful for debugging? And I will take this, Tyler, if you don't mind. So this is, again, generative AI is an evolving field right now. Things change every week. Definitely in our test, Tyler and I, and the community also showed some interest in that and shared some of their findings. It definitely looks like that it works pretty well with some types of debugging kind of scenarios. And it never hurts. So it's free, so you can try it. And I'm sure they're getting better and better with specializing in specific languages and understanding their syntax better. So yeah, so in our experience, it works. It worked, and it gives you meaningful feedback. But again, like anything related to generative AI, you have to take its feedback with a grain of salt and make sure you also know what the context is. And that is going to be the next one is the final question. So kind of long questions. I will try to paraphrase it as well. My model time stops during simulation at a specific time. The console or problem view won't show any error message, but when I pause the simulation, the application will freeze and stop working. What approach would you recommend for debugging? So let me paraphrase this question again. So there are scenarios that you see that the model still running, looks like it's running, but the clock, the virtual time doesn't move forward and there's no error messages basically, but it's kind of hanging in that state. And that's a kind of a common scenario. So I think Tyler can address that case.
Yes. So in that case, the model is still technically running, but there's something stopping it from continuing the simulation time. And that sounds like it's a problem with some infinite loop happening, or if there is an event that schedules itself, sometimes like with dynamic events, if you're creating as part of the logic of that, if you create a new dynamic event as part of that action, that can cause an infinite loop to start happening based on the logic. So in this scenario, it's best to go through your code and look for things like while loops to see if the conditions are not being met. But other than that, if you, again, kind of circling back to this, if you try fixing the seed and make it reproducible, then you can identify where in the model time an instance of that problem is occurring at, so that you could stop, replay it, jump to that time, and then kind of step through the model events that are happening based on what you're doing in the, it's accessible in the developer panel. And then you can see exactly where this occurs at, and that can help diagnose where the problem might be occurring at.
Okay, thank you so much, Tyler. Before we leave, I wanted to bring one other topic to your attention. As you probably know, we have our annual conference coming up next month, September 5 and 6 in Nashville. So if you go, you can see it on the screen. If you go to our website, it's the first thing. So there's a kind of way to get into this AnyLogic conference page, and you can register there. The program and the agenda for the conference is, most of it is there. It will be updated today or tomorrow as well, so you can see the full list of presenters. It's pretty impressive. And one thing that if you haven't joined us in the past, and you can actually see the previous conferences on our website, the video recording and the presentations are there. But if you haven't joined us in the past, one really interesting kind of aspect of our conference is that big users and advanced users at enterprise level use case of simulation demonstrate what they are doing, and these are real case studies, which is hard to find because most of the time it is sharing what you're doing with simulation modeling for strategic or tactical reasons is a challenge. So we really work hard with our community to make this happen for you. So please join us if you can make it. So that would be for the conference. And regarding this current webinar, as I mentioned near the end, all the models that you saw during this webinar will be available to you as part of the follow-up material, and this video recording will be put on our YouTube channel, so you have it for your reference in the future. And you also get a short survey right after this webinar ends, so please help us by giving us some feedback. Thank you again for your time and attention today, and hopefully we'll see you either in person in Nashville or next time in the next webinar. Thank you so much.
Thank you.
Bye.